So yes, I already introduced myself earlier. My name is Adrian Lanning. I am a co-founder of a company called Share 911, and one thing that we needed to do was upload floor plans, upload images to our service, and we didn't know how to do that. So we turned to our good friend Curtis here, and he did it for us. So, we sponsored this development and wanted to let Curtis show off what he's done. So Curtis, maybe you want to introduce yourself.
Hey guys, I've done a few talks here before. My name's Curtis Larson. I'm a freelance software developer for about 6-7 months right now. I've been doing Meteor for over a year, I guess, at this point. I love coming to these talks. Just want to show off what I helped Adrian build, and hopefully some of you guys can find it helpful. Don't have to rely on like GridFS or one of those other not great solutions.
Yeah, we actually had some people come up earlier talking about migrating off of GridFS, which is highly recommended. So I'll let you do the page down while I do this part. So this is what we're going to talk about, high-level overview. The AWS config, you might not normally see that, but in this instance, it's very important. All right, so let's get to the demo.
All right, so we're going to upload some kittens. That's the goal of today. Also, before I show the website, for anyone that wants to see anything that we talk about today, it's all on GitHub. You can check it out. Quackware is my GitHub name, and it's Meteor Slingshot Example is the name of it. You can check it out. There's a README with all the AWS confusing stuff we're going to be talking about later, and it has all the files, so you can go check that out. Let you take a picture. There we go. All right. So the basic premise of this sample app is it just has Meteor account's password. It makes sure that you register and log in an account, and then it'll have a file upload that lets you upload pictures to an S3 bucket that you permission for yourself. And we accomplish this super easy using a package called Slingshot. So let's go ahead and walk through it. We're going to sign up. You guys are probably familiar with this UI.
So I don't know if you saw that tip earlier, but if you're doing a live presentation like this, do not let unauthenticated users upload to your service because you don't know what pictures they're going to upload. And this goes out on YouTube.
We're running this on localhost, so
Kittens,
please. All right, so we've created an account because in like 2 seconds because Meteor is awesome, and we're just going to go ahead and choose a kitten, and we're going to upload it. We have a little progress bar that fills to 100%, and what this basically did is it took this image, it checked with our server saying, hey, are you logged in? Hey, do you have permissions to upload this photo? It went back to the client and was like, okay, we have permissions to upload this photo, and then it sent that photo directly to Amazon. So this big image, it could be ginormous, never actually went to our server. So that is awesome, just because it saves us tons of bandwidth. If we have like mobile users that we don't want to send lots of back and forth requests, that's a great thing about this Slingshot package that we utilized. And if we want to say goodbye to the kitten, we can delete it, and it disappears. What this does is it deletes it from our internal Meteor MongoDB database that we have that just stores metadata. It stores things like the URL, the key, the owner of this image, and it sends a delete request to AWS S3 just to kind of get rid of that out of our bucket. And that's pretty much the gist of the demo. It might seem really simple, but a surprisingly amount of work, even for Meteor, went into this. But it was actually straightforward. Probably the hardest part about this entire thing was just configuring Amazon, because IAM or whatever it's called is a pain to configure any kind of thing with. So let's go back.
That's why we hired him.
Just a couple hours here and there. All right, so Slingshot Overview. So let's go ahead.
All right, cool. So the Slingshot package repo actually has a really great picture that we're going to pull up right now that kind of better illustrates what we were talking about. So in a traditional upload system, you probably have the data of the image going through your server and then to your ultimate endpoint where you're storing it. That works, but it's not great from a scalability standpoint. So the alternate way is that you have the data go directly from the client machine to your storage, but then the issue is how do you authenticate that? How do you secure that? So what Slingshot does and what AWS allows is this concept of getting a secured token. Like the client talks to the web server. The web server will talk to AWS and say, hey, give me a secure token for this resource. This is what we're going to put there. We get the secure token back. We tell that token to the client. And then as long as the client initiates that transfer in a certain amount of time, then it has permission to upload that. So that's how we're actually securing it. So now if we'll go back to the slide, we can talk a little bit more about some of the other nice things that Slingshot does for us. So, so here's where we're retrieving that authentication token. Then it will handle uploading using the S3 APIs to actually perform the data upload for you. And it has these nice reactive variables for progress. So it was very quick since we're running on localhost, but there was actually an integrated progress bar in the example repo that you guys have access to.
So yeah, we're going to walk through the code, I guess. Just go through some of the important parts. Let's not forgot to close out my other stuff. All right. So, what should we probably start with? I guess.
Maybe you should start with the slide and just talk a little bit about the
that's a good idea. So I guess some important points that we're going to walk through is kind of what we've been iterating over before, how we validate this user input without actually sending the image to the server. We both do a validation in terms of AWS, and we do a validation ourselves with Meteor. We also store these basically metadata, this information, in the MeteorDB rather than storing the entire image file in there. And we use another package called peer library to actually delete the image from S3. This was necessary because Slingshot doesn't actually have a delete functionality. And there's a bunch of other cool stuff in there. So the template files are very simple if you guys understand. Let's see, options plus. If you guys have seen Blaze at all, you kind of, this is pretty simple for you. Just a simple input file that allows you to upload an image. You can see in here, you can see some of these reactive variables that we were talking about. We check if we're in the process of uploading, and we also use this progress helper to basically say, okay, we're this percentage complete. And we can actually take a look at some of those template helpers here. We see uploading. It just says if the progress is greater than 0, and then we also have the progress variable itself. And we have the input file. We actually just do a change on the input in terms of a template event. And all this does is we have our Slingshot uploader here, and it just sends the file. It's kind of a little bit deceptive. It doesn't necessarily send the file to the server, but it does all of its Slingshot magic behind the scene. And all it returns to us is the URL of the server, of the image that's been uploaded to S3, which then we can use a simple Meteor method to save it into our database. And all this other stuff, I think, is just, it's just basic, nothing super important. And here's just where we just show our uploads, each of the uploads from our database. So let's check out that, because that might be interesting. Basically, all we're doing here is we are basically subscribing to an uploads collection, and we are just have a template helper called uploads that just returns this subscription of these uploaded images so we can display them to the user.
And that would actually be where if you had other metadata, which you wanted like a label or a description or something, that would be stored in that kind of collection.
Yeah, so let's go ahead and take a look at this. You can see very simple. All we have is the owner, the user ID from account's password, and we have the URL of the image that was uploaded on Amazon, so it's that long S3 URL. And then the key is basically the file name of that URL, which we use to delete it. That's how Amazon understands to delete an image from a bucket. It just takes the file name and it takes some other parameters, and then you can send a delete command. And we use simple schema. We use, I think, collection 2. I don't know if that's super necessary though. But yeah, very simple kind of MongoDB stuff. All right, so we kind of get a peek into some of the Slingshot stuff that we're doing. We are able to do things like limit the type of image that we can upload. We can also limit the size, so Slingshot will return a nice error to us. Yeah, and let's go towards probably the best file here. So this is basically how we can both authorize Slingshot. Let me increase this a bit for you guys. The authorize function, basically, you can basically throw any sort of Meteor error you want if you don't want the user to be able to upload an image. So in this case, all we're doing is we're checking to see, is the user logged in? Otherwise, we're just going to throw an error. This temporary credentials is a little bit more complicated. It actually uses Amazon STS, which is Security Token Service, something like that. I always forget the name of it, to actually generate this credential that Adrian was talking about before. And it returns it to the client so that we actually have permission to send that request from our client to the Amazon server. And the key is just a way to generate the file name. In this case, we're just generating a random number and adding it to the file. And startup basically just has configuration options. The rest of this is straight basic Meteor stuff. The one thing is delete. When we send that delete, we actually use Peer library, just the straight up Amazon SDK in order to delete the file. That's the one non-Slingshot thing we're using in this case. And you see the save upload that was called at the very beginning. That's where we're inserting things like the URL, and the key you see is just the split of the URL. It's just the file name. And yeah, that's pretty much the gist of the code.
Cool. Let's go on to
pretty straightforward.
the AWS config.
Oh boy. All right. So this took a long time to figure out because I was unfamiliar with IAM to start off with, and there's a lot of like small intricacies here and there in terms of permissioning that I just had no idea about. So luckily, if any of you guys want to do this, there's a nice guide that gives you step-by-step on how you can implement this exact same thing.
And this is what I think is missing from the Slingshot documentation. Like, it would be great if they had this.
Yeah,
well, now they do.
Slingshot does things other than S3, but I think it's mostly used for S3.
That's true.
And this is like, yeah, it's definitely what I was looking for when I was looking at their docs. But yeah, I basically wrote up step-by-step on how you go into, say, the users, and you create a new user called Meetup, and then you can assign it a specific policy that says, okay, you can only access this S3 bucket, and you can only do things like put, get, delete. And then you can also have your bucket, which is, I'm going to upload an image so you can see something in there. So let's refresh that. All right, proof I'm not lying to all you guys. There it is. Yeah, and then you also have to do things like set up the bucket policy to say, okay, now this user has this access to this bucket. And then you also, for Slingshot's sake, because you're not uploading the file from the server, you have to also set up a CORS configuration, which is cross-origin resource sharing. I almost forget that one. Yeah, so there is a full, step-by-step guide, and we also provide each of these files with kind of placeholders where you can put in your bucket name, where you can put in your IAM username, you can put in your account ID, etc. So all the resources are available for you if you want to be able to do this yourself.
And we actually did this for our production system, and it worked. Like, if you follow the instructions step by step, it does work.
Yeah, I think that's, I don't know if I want to walk through creating it, so we'll just continue.
Yeah. Cool. So the example is pretty awesome. There are other features that you probably will need for a production system, such as management, drag and drop kind of sorting. There's sort packages out there that you can use. For our production system, we use one called Slip, which was pretty cool. Access control. So right now it's very simple. In the example, you just say, are you authenticated? And then that person is the user. Is the owner of it, and that's the one that can delete. But probably you'll have groups of users that you'll be giving access to. Maybe you have private galleries or something like that, and also customizing the metadata. So that is our talk. Thank you very much. Any questions? Yeah.
So I noticed that you had max size set to null, and I was sort of surprised that does Slingshot allow that?
Basically says there is no max size.
Right, and I'm saying.
Oh, sorry. You asked that I had max size set to null in Slingshot, and I set it just because for these, testing purposes, we don't really care if there's a max size.
Okay.
So basically that means infinite from their perspective, which you absolutely should not allow on your production server.
So I guess it's the user's responsibility when they go to the website. They would be the one most affected by that because they're actually initiating the upload to S3. So their connection is the one that's going to get trashed, not ours. But yeah, we should set a max size.
I have a question. Why did you have to use a native call for deleting from S3? Why couldn't you do it through Slingshot?
The question was, why do we have to use a native call? They just didn't have the functionality that I was able to find. So it's just a minor inconvenience. Maybe someone could submit a pull request to add that. I don't know if they want to add that or not.
Yeah, probably. I mean, Slingshot's whole deal is like they upload, and they do that really well. So we use the peer library package to handle the rest of the APIs, and it worked really well. So separation concerns, it worked well for us. That's cool.
Thank you.
Yeah.
Is the S3 URL public when you upload a file?
Yeah, the permission set up that, is the S3 URL public? Yeah, I believe one of the permissions was set up so that.
So that's the kind of thing that you can set in these AWS policy things, I believe. For this specific project, our goal was to make these images public. So I'm certain that you can configure that kind of thing. Because when you upload manually to like an S3 bucket, you can check the box that says make public or not. So that was just one of the requirements of.
I mean, just to clarify, they're public, but you can attach a token to an image such that it's only accessible within some restricted context.
So the comment was that you can restrict it further if you don't want to make it public.
And that's not through Slingshot.
That's purely
That's not through
S3,
Slingshot,
yeah.
right? Yeah.
Do we have kind of what we're used to, the optimistic rendering that reads the image in front, and then if there's an error, that's handled gracefully?
That's a great question. Optimistic. Do you get optimistic rendering of the image? In Meteor, we call that latency compensation, and we do. Yeah, Slingshot supports that. How it handles errors, I'm not 100% sure.
So you saw, like, when we had that authorize function, we just kind of threw an error there. And, I mean, any errors that you actually do have from the front end, where did I do it?
Okay, yeah. So you can catch the error, and then you might have a flash of the image where it's doing the latency compensation, but then you'll get the error state.
Yeah, you can have whatever errors you want or just return from this send. It's kind of like a Meteor method, and then
That's awesome.
It has that error stuff.
Any other questions? Yeah.
I have a couple questions. First question is, since you're bypassing your own server and going straight to Amazon, is that faster than going through your server?
Yeah, way faster.
Great.
Absolutely. And also, so since you're bypassing your own server, is it faster? Absolutely. It's also more scalable because that's less load on your servers, your CPUs, your I/O.
Great.
Yeah.
Second question.
Yeah.
S3 supports more than just images. You can upload other Slingshot as well. Does that support uploading more than just image media, but also MP3s or something?
Yeah. So the question is, can you do this with other things besides images?
Yeah, I think Slingshot's generic for anything. We just did it for images in this case.
I think there was a question back there.
That was my question.
Oh, that was your question? Okay, cool.
Can you initiate a Slingshot upload from the server?
Question?
The question is, can you initiate Slingshot upload from the server? Thank you. I don't think you can through Slingshot. Maybe you can, but that's an excellent case for using the peer library S3 just straight up thing. I mean, the really great part about Slingshot is it handles that kind of auth token for you. But if you're doing it from the server, you're already, on the other side of the vault. Like, you have authorized yourself, so you don't really need to handle that whole handshake. You just stick it up there.
Justin?
So if you would want to like optimize the image or process it later, can you as a server still download and then upload to that same URL endpoint?
Yeah, that's a great question. So what about if you want to process the images before you use them somehow?
Like thumbnails, stuff like that. We were actually just talking about that before this talk. I don't know if the Slingshot doc has a way for you to like transform the image before you do an upload. They might. You can always grab the URL from the collection and do whatever transforms you want. I'm not sure if it's as robust as, say, GridFS, where you can actually do these live transforms as the image is being uploaded. I mean, that's something I'll have to look up because I'm not completely sure.
Actually,
about that.
we explored that since you completed your project, and for us, the general case is you put it where you want in the bucket. You don't have to make that public. So you first make it private, then you process the heck out of it, do whatever you need to, and then once you have that final processed image or file, if it's a WAV file or whatever, then you put that in the final bucket that you will be making public or granting access to. And then that's the URL that you store as the metadata in your Meteor database side.
Adrian, in that case, with the processing, you're saying the processing would happen probably offsite on some cloud server someplace.
Yeah, where would that processing happen?
Right.
It's totally up to you. You could do it in your Meteor app, not recommended. Probably have another thing that your Meteor app would trigger, like a work queue.
Some microservice or
Yeah, or Lambda from AWS.
I mean, that's a great use case for that.
For Lambda.
AWS Lambda.
Yeah.
Processing images, thumbnails, and so forth.
DigitalOcean Lambda.
Or DigitalOcean's version of Lambda, since DigitalOcean is kindly hosting this DevShop. Yeah.
Slingshot assumes Blaze, but is it also possible in Angular or React?
So the question is, Slingshot assumes Blaze. Is it possible to do with React or Angular?
I don't think Slingshot assumes Blaze at all. I think it's,
Oh.
yeah. I mean, there weren't any Blaze specific things,
Well-
unless that we added.
Well, they have the reactive vars, so
But
and they have.
You can
latency
still
compensation.
put those in, like, they get Meteor data in React, for example.
Okay.
And still have that
Yeah,
reactive.
it's so we do this in the packages that I maintain, where you have nice helper template stuff that it supports Blaze, but it doesn't mean that the rest of the package can't be used in other circumstances. You just need to kind of recreate those helpers
Yeah.
in your own environment,
I see.
Angular, Blaze, or React.
I think there was a question back there.
Yeah.
So what made you choose this over, say, Collection FS?
So what made us choose this over Collection FS? And we wanted to not have that data touch our servers at all. We wanted to just go straight to S3 because that's the cheapest way for us, also the most scalable. Any more
Any other
questions?
questions?
There is one more thing I wanted to mention. Currently, we haven't figured out how to make it support IE9, so browser support. IE9 is a big user base for us. We found that it wasn't that big of a problem. We just have a detection that says, hey, if you're using IE9, please use a better browser. And our users were fine with it. Pretty much everybody has another option available at some point.
Yeah.
So
I think they even said that in the README. Like, we don't support IE9.
yeah. All right, guys. Thank you very much.
Thank you.